Let's first define what machine learning is, because lots of times people confuse machine learning with AI. AI is a hot term, correct, nowadays, and people use those two terms in a funny way, although they are different. Machine learning as a concept, I think, was introduced back, I'm tempted to say in the 60s, but I might be wrong. So basically, you have an algorithm that is running in a loop. It has specific rules that says, we think if these rules happen, then this particular outcome will happen. The perfect example for machine learning is the MRI. Scan an MRI and you're able to determine whether there's cancer or not. You start by defining specific functions, specific data points to say if there's data points that match 1, 2, 3, 4, 5 things, then there is cancer. You put that through the algorithm. So a human says the parameters. The algorithm runs, evaluates an image and says, okay, let me try and look for pattern. And we start with what we call a data set. The data set is like, okay, here's a whole bunch of MRI scans that we know for a fact have cancer. Here's the functions, here's the inputs, analyze and say if they match criteria number 1, 20%, and criteria number 2 at 30%, and criteria number 3, there's a good chance that there's cancer. So the machine tries to use the function to identify the pattern. After you're done with the learning set, then you take another set, you run it through the machine and you say, okay, well now you've learned, you've established some patterns. Why don't you go through this test set to determine whether there is cancer or not? The machine runs, yes, there's cancer here, there's cancer there, and then we compare it to the actual data. And then we say, yeah, hey machine, this is wrong, this is right. So the machine again learns and tries to fine tune the algorithm. There's an involvement from an analyst, correct, who builds the initial model or function to describe the relationship between all the different factors that you can see on an image. In the case of MRI, in the case of inversion optimization, the pattern that we're looking for is the certain behavior of visitors and what they see on the website, and the ultimate output, for example, in conversion optimization, somebody converting. So we're trying to analyze, we say it might be price, it might be where they landed, it might be the layout of the page, it might be different factors. The machine learns and then we test somebody converted. So now when somebody's landing on a site, do we present them with certain information in certain places and then see whether they convert or not? There's two types of machine learning algorithms. Some they learn once and then they're done. Some are constantly learning. This is what we call reinforcement. In the reinforcement process, basically the algorithm is always looking at the accuracy of its prediction. It looks and says, oh, I predict that this MRI actually has cancer or it doesn't have cancer. And then it compares and says, oh, I made a mistake here. Let me try and improve. So the machine is learning and improving itself. The use of machine learning in conversion optimization has been limited. In digital marketing, it's had its benefits. Machine learning, for the most part, just like I gave you an example, is a classification problem. Based on certain factors and criteria, do I classify certain output in a certain way? For example, let's say I'm going to analyze customer reviews. Product has 1,000 customer reviews. Are they favorable? Aren't they favorable? I can use machine learning to learn and give a final judgment. I can analyze social media and how social media is talking about a certain topic to determine the sentiment towards a specific topic or a specific brand. Machine learning as a field is semi-used in A/B testing. The problem there is trying to determine based on a set of variables, what are the changes that I'm going to make in a layout of a page or a visitor journey across the website to improve conversion optimization. You need a large data set in order for you to effectively use the machine learning algorithm to make a determination and classification. That automatically limits the number of sites that can use machine learning. I'll give you another example from machine learning and its use in digital marketing. The company that we worked with, they only work with apparel companies. You come to a website, it's female apparel. You look at a particular item. Below the item, they show you some influencers who might have worn that item in different styles. You're looking at the shirt, well, you can match it with pants, or you can match it with a small skirt, whatever it might be. You're clicking, you go to Instagram and you come back. They can look at which influencers you clicked on over 3 or 4 pages, and they can actually classify you to determine what kind of clothing you like based on a couple of clicks. And based on that, now that I know which clothing you like, the category pages and how they are displayed to you look a lot different than how they're displayed to somebody else. And all of a sudden you're thinking to yourself, I'm like, oh wow, this site really, I love their items. Yeah, you love their items, except that the fact that they understood your shopping preferences, your style, and now they're showing you items that appeal to you using machine learning, which is very powerful. I think eventually there will be space for machine learning conversion optimization. It's not not heavily used yet. There is distrust between conversion optimizers and machine learning software because we think that I still need to use my brain to do the analysis. I think there's place for machine learning conversion optimization. It's not going to replace conversion optimizers. It can help them make their performance better. So eventually we'll get to that point. Not yet, but we'll get to that point. Price optimization and using machine learning and price optimization is an area where machine learning is very powerful. Setting the right price for a product or even a service for that matter is challenging. There's so much literature about it when it comes to economic theory. Ultimately, the goal of a company is to maximize its profits from any unit that it sells. Let's take an e-commerce company. We are pricing an item. We're thinking what price we should sell this item for if we want to sell a certain number of units in a week. What is the right price for that item given all the different circumstances that play into pricing an item? There's the economic situation, correct? There's the competitors. There is the supply chain issues. An item could be priced at $100 today because it's available. You can buy it from other competitors. All of a sudden, there's supply chain issues. Webcam goes from $100 to $250 because just there's issues and there's so much demand for it. Machine learning can look for the impact of all these different factors to help us understand how we actually optimize the price, help us understand how customers would react to different pricing points. Should we be pricing this webcam at $250 or $180 or $100? Giving all the different circumstances that are going on in the economy at some point and given how customers demand this particular product. The quality of a machine learning output depends on the inputs. We talked about the function. An analyst actually programming that function, looking at all the different inputs to make a determination about the right price. When it comes to looking at an MRI and determining whether it has cancer or not, well, we have like kind of the medical field and the image, all the factors are there. When it comes to price optimization and using machine learning for price optimization, there are things that are really difficult to manage. There are many factors that are sometimes difficult to come up with a formula for. Companies who are successful, they're able to come up with an initial price for an item, a best price, a promotional price. There's different prices that you can come up with using machine learning. There's other pricing strategies that are out there. There's dynamic pricing. There is set pricing based on profit. Dynamic pricing, you're always looking at your competitors. You're looking at their pricing and you're trying to match, which is, by the way, what we see with airline tickets most of the time. That's a lot different than machine learning. Application of machine learning on pricing can be very interesting. It's challenging, not easy. The statistical analysis around it is very fascinating. It can help retailers maximize, but the software that does that in a good way is too expensive for the small retailers. That's the other problem that you have with using machine learning when it comes to pricing. Software that does this really well is too expensive for the smaller guys. Lots of the software that's available for the smaller retailers claims to use machine learning, but it really doesn't. Just to give you an idea about the cost of machine learning, remember the company that I mentioned using machine learning to determine the style? Each run to do an analysis on a data set costs them $5,000. Each run. Sometimes it costs upward of $25,000. Imagine how expensive that is. Not every retailer can afford. And this is just the cost for the software company. They still need to pass that and they still need to make profit. That just tells you how expensive the software can get.